This JetPlanner 4.0 tutorial explains how to import a KML file into the JetPlanner 4.0 application to simulate the feasibility of laying cables in underground ducts. A KML file, as you can see here, is a text file containing geospatial data. This data can be used by a GIS software, geographical information systems, which, as you can see here, allows you to represent the real world in different layers with layers of information about land use, terrain elevation, seeing streets, or also customer addresses. For example, here we see in yellow the representation of the KML file we will create and simulate in that tutorial, which represents the underground duct where we will simulate the feasibility of cable installation with JetPlanner 4.0. To create an KML file using the free Google Earth application, you simply need to launch your browser and go to google.com, then select from this menu the Google Apps menu, which will take a few seconds to start. The first thing to do is create a project. So, we will click on New to create a project in Google Drive. But in our case, we will create a local KML file. So we click here to create our KML file. We will rename it to find it more easily later. Then press Enter to confirm the selection. Then we need to find the location of the pre-installed ducts. We will choose a location near the Plumettaz factory in Switzerland. Once the location of the duct's starting point, where we will lay the cable, is identified, we can clear the search result clicking here and then zoom in using the mouse on the starting point of the cable laying. Then, by clicking on this icon, I will be able to place my starting point with a left mouse click and then place the different points of the path with left mouse clicks. To move the image, hold the left mouse button. Move the image with the mouse while holding the button down, and you can continue like this, adding points one after another. It is also possible to zoom out on the map to get a broader view and place points even approximately, since they can be corrected later. This is a way to save time, especially when the paths are several hundred meters long. When we reach the end, we can click the Done button to confirm the trajectory and also save the project. You need to name it so that you can easily find this trajectory in the JetPlanner 4.0 later, and then press Enter. It is then possible to modify the points that have been placed so that they exactly match the trajectory of the duct, where we will simulate the cable laying. To do this, use the left mouse button to move the points exactly to the desired locations. Once the trajectory has been properly edited, you need to export the project as a KML file. By clicking here, you can access to the KML file automatically saved in the Downloads folder of your computer. It is now possible to close the browser and close the Google Earth application. Once you have edited the KML file with Google Earth or received a KML file generated by a GIS system, you can then launch the JetPlanner 4.0 application. As explained in the introduction tutorial video of JetPlanner 4.0, you must enter your personal login and password to connect to your account. It is possible to create a new project, or in this case, open an existing project to import the KML file. It is possible to add the file to the project by opening the File Explorer, selecting the generated KML file, and adding it to the project. Then we select the section of our project. Click on Trajectory and replace the current path with the one imported from the KML file. To proceed, click on Open Trajectory and then select from File to select a file from the Downloads folder of your computer that contains the file we previously selected. You can also select the file we previously imported into the project called My Project, and we can directly import this trajectory into the project. When the KML file contains several sections, you need to select the section to import. In this case, there is only one section. If the trajectory is complex and contains thousands of points, it is possible to simplify the trajectory to optimize the application's calculation time. Then, for a standard KML file imported from a GIS system, we can select the first option to import the elevation data contained in the KML file. However, when the KML file is generated by an application like Google Earth, which does not contain elevation data, you can click this option to add elevation data from the JetPlanner database to the file. We then enter a minimum curve radius of 2 meters between all the imported straight segments, because a KML file does not contain information on the curve radius between the different segments. To correctly manage the creation of this 2-meter curve radius between the different straight segments imported into the KML file, it is possible to choose between 3 adjustment modes. Either a mode that preserves the segment lengths, a mode that preserves the trajectory geometry, or a mode that preserves the total length of the trajectory. The first mode preserves the segment length. We see here in red the first and second imported segments, between which we add the 2 meters curve. The total length of the new trajectory in blue becomes longer than originally drawn. The second mode preserves the geometry of the trajectory as drawn in the GIS system or Google Earth. We see the first and second base segments in red, which have been shortened to integrate the 2-meter curve radius. The total length of the trajectory will be reduced, but it will correspond to the actual terrain with the real duct curve radius. This is the adjustment mode to use with KML files imported from GIS systems or Google Earth. The third mode is an expert mode that ensures the total length of the segments is preserved. Base segments 1 and 2 are reduced to incorporate the 2 meters curve radius, the total length being equal to the length of the initial red segments 1 and 2. In our case, we have therefore preserved the geometry of the KML file that we drew with Google Earth, and we can now import the trajectory into JetPlanner 4.0. We can then see the elevation profile of the path we have drawn, and also the overhead view of this trajectory with all the straight segments and curves. We can now visualize the result of the simulation by clicking on Simulation. First, in the simulation results in green, we can see that the cable can be installed along the total trajectory of 769 meters. We can see here on the results graph the blue curve, which corresponds to the force required to install the cable, with an exponential effect at this point to pass the sharp angles in the trajectory. And we can see that this blue force curve gets dangerously close to the red limit, which represents the force limit of the jetting machine system that pushes the cable, as well as the airflow in the duct. That will pull the cable toward the end of the duct. We can also see, by adjusting the parameters, that a slight variation in the friction coefficient could lead to the failure of the cable installation in the duct. However, if we install the cable from the opposite end of the duct, that is, in the other direction, we will benefit from the negative slope effect, and thus we have a much higher chance of successfully installing the cable. Now, you know how to create an KML file with Google Earth, how to import this KML file into JetPlanner 4.0, and at the same time, how to import KML files from GIS systems. Thank you for your attention.